All right, good evening, everyone, and welcome back to another lecture for cloud computing for the winter 2023 semester. So last time we had kind of left off with our discussion, starting off to understand the concept of virtual private clouds, okay? And we had also kind of delved into the VPC service for a particular region, and we were talking about the different aspects of VPC or the overview that you can see for your virtual private cloud by going into that particular service, right? So we're going to continue our discussions along that particular concept or this particular service. And the two important things that we need to first cover is basically to get an understanding of what is classless interdomain routing, okay, or CIDR blocks as AWS calls it, which is a way of representing the different IPs that are available at your disposal that you can use to assign for any EC2 instance that you kind of create or declare within this VPC space. All right. We will also understand a little bit about firewalls, the two categories of firewalls that are out there, and how security is implemented within these VPCs and where do they essentially apply in terms of protecting your EC2 instances that will be declared within VPC, okay? So overall, when you think in terms of a virtual private cloud, you always have to keep this diagram in your mind, right? So essentially, when you try to deploy a VPC or when you kind of log into your AWS service, a default VPC is created for every availability region, right? So for example, if you think about it in this way, that we are currently in the region for, if your availability region is, let's say, Ohio, and Ohio has 3 availability zones. So what would happen is anytime that you create an account for AWS platform itself, right, instead of you creating your VPC, a default VPC is kind of created for you by AWS, right? And that VPC is going to belong to each and every availability region that they have in their service disposal. So that is the important thing that you have to remember, that whenever the account is created, for every availability region that is available on the AWS platform, a default VPC is created. And then within each availability region, for every availability zone that is present, a default public subnet, okay, or a public subnetwork, subnet is the short form, is basically created for you. So this example that we were talking about, that is the Ohio region, has 3 availability zones, right? So the architecture of the default VPC that will be generated for you would be in the form of having 1 VPC and then 3 public subnets within that VPC, okay? And then associated with those individual public subnets, you will have a public IP address since they are public. And you will also have certain gateway routers that will, again, essentially allow you to have the communications of your EC2 instances that will be kind of declared and kind of hosted within a public subnet or a private subnet to the outside world and the outside services that AWS offers, the other AWS services that it offers, such as the S3 storage bucket, or if you think in terms of attaching any kind of database service, the relational database service is present, the DynamoDB, the NoSQL service, the NoSQL database service for AWS and those kind of things. This allows the EC2 instances, which will be present within each public subnet using that public IP that is associated to each public subnet to communicate with the outside world. Okay, so that is basically the default architecture that you can create for your VPC. But going beyond that, that is going beyond the default VPC architecture that will be generated for you by AWS, you yourself have the capability, of course, just like for any service, to create your own architecture for your VPC, right? And in that architecture, you have to keep in mind that when you generate your subnets, okay, you can classify them either being a public subnet, with the categorization of the public subnet being the fact that it will have a public IP address, such that any EC2 instances that will be declared within that particular public subnet will be able to communicate with the outside world, as well as the bidirectional communication, that is the outside world can also, using that public IP address that is associated with the subnet, will be able to communicate with the EC2 instances that will be associated to that public subnet. The other category of subnets that you can create is basically a private subnet. So the only distinguishing factor, or the main distinguishing factor between public and private subnets, is that the private subnet will not have a public IP address associated with it, right? So what it will have is basically, just like the name suggests, it will have a public IP address. So the communications between these different subnets, okay, you can have more than one public subnets, you can have more than one private subnets, or you can have any k number of mixture of public and private subnets, happens using what is known as a VPC router. So that means the only way to, or not the only way, one of the major ways in which you can reach out to any EC2 instances that is being declared inside of private subnets is through the help of this VPC router. And in that communication, that is, if there is a source request or you're looking for a source host, that source host has to be present inside the public subnet unless you do certain changes that allows you to directly communicate with private subnets itself, right? So in addition to that, the entire VPC has basically an IG, or an internet gateway. So remember that internet gateway is nothing, physically speaking, it is nothing but a router. It's similar in terms of its physical operations, similar to any other router, but conceptually, it has a special functionality, that is, it kind of bridges the gap between the VPC that you create with the outside world. That is, whatever you have here, that is, if you're trying to communicate with your EC2 instances, let's say that is present inside your public subnet, from a local computer like we are doing right now, okay, and we will be doing going further, then that communication will generate from the outside world, that is the public internet, go through the internet gateway, be received by the VPC router, and then it will be sent to the public subnet, okay? So similarly, if you want to communicate with the private instances, you cannot reach out to that using the internet gateway, because the route table for your VPC is not associated with the internet gateway, since this is a private IP address and this is not a public IP address. So essentially what happens there is that you have to take one more step, and then this communication will go to the VPC router, and then the VPC router can forward that communication into the EC2 instances that will be associated to any private subnet. Now, of course, there are certain exceptions to how you can communicate from the outside world to these EC2 instances, which will be associated with the private subnet. So just to give you a high-level overview, is that two options is you can establish a virtual private network connection to the EC2 instances, which is present in the private subnet, that will allow you to directly ping or tunnel into the EC2 instances, which is privately present within your VPC. The other option is to create what AWS calls as endpoints, right? So you have direct communications, you create these endpoints for these EC2 instances, and then allow an AWS service to directly communicate with the EC2 instances that will be present inside the private subnet. So this is kind of like the high-level overview of the architecture of your VPC. So anytime that you're trying to create a VPC, there are a few things that you have to keep in mind, is that a VPC can span across multiple availability regions. So what does that mean? That means that I can create a VPC for, let's say, the Ohio service region, right, or availability region. I can also create, let's say, another VPC, let's call it VPC2, and I can deploy that in an availability region, which let's say is Virginia, right? In that situation, we will take all of the availability zones that is available in Virginia, which in this case is basically 6 availability zones, and we can create multiple subnets within each of those availability zones. Also remember that you don't have to be restricted to the creation of a single VPC within a single availability region. What that means is that within any given availability region, you can create multiple VPCs. So that means I can create one VPC whose architecture might look like this within the Ohio region. I can create another VPC, let's call it VPC2 Ohio, and I can create, instead of a mixture of public and private subnets, I can probably create 3 public subnets within that particular availability region. Now, each of these subnets can either be present in a consolidated fashion within a single availability zone, or it can be spread across, or it can be declared across all of the different availability zones that is present within that availability region. So as we just discussed, that the default architecture of a VPC creates one public subnet per availability zone for a given availability region. So that means if I switch my availability region to, let's say, Virginia right now, then the total number of subnets that will be available within the default VPC architecture will become 6 public subnets. So it will, AWS will provide that to me, right? So when you are creating your own VPC, you also have to keep this policy in mind, that whenever you declare a subnet, you can have all your subnets associated to a single availability zone, or you can create an architecture that is spread across all the availability zones that is available within a given availability region. So these are some of the options that you have available for you when you are trying to create your architecture for your network, right? And then after that, when we move into EC2 instances, basically when you declare your EC2 instances, then you actually have to declare to which subnet that instance will be associated to within the given availability region where you are declaring your instances. Okay. So moving forward, as I mentioned, that for every VPC, there will be a VPC router that will be associated to that particular VPC that allows you to kind of communicate between your public and private subnets that are available, or between the public subnets that are available. If you declare everything as private, then the only thing it will be that you won't be able to connect with the external world or the public internet infrastructure or other AWS service unless you establish a VPN or specify endpoints, that is specific IP addresses of what you are trying to communicate with, right? Or who you are trying to communicate with. So this route table example of for a VPC router is associated with a public subnet being present, right? So as a result of that, it gives you two different set of IP addresses, okay? So one of this target set of IP addresses is for the internet gateway that we just discussed here that allows you, due to the presence of a public subnet, to communicate directly using that internet gateway with the outside world. So that outside world could be a local computer like the ones that we are using right now. It could be other AWS services, such as storage services like the AWS S3 bucket, or the AWS database service, such as RDS, and the AWS DNS service, such as Amazon Route 53, and so on and so forth, just to cite a few examples. In addition to that, your VPC is also going to get an internet gateway. The internet gateway route destination is always represented as 0.0.0.0/0. Okay, so this notation where you see this IP address range and then a slash followed by a decimal value, right? This is known as a CIDR block. Okay, so this is what we call as a CIDR block. Okay, and what the CIDR acronym stands for is basically the classless interdomain routing, right? So this is basically a notation to kind of give you an idea of all of the available IP addresses that is available at your disposal, which can be used and then assigned to these different EC2 instances that you will eventually create, or they assume that you will eventually create within each of these subnets, okay? However, keep in mind, and we will talk about how to kind of translate these CIDR block notations to basic IP addresses, like the IP addresses that we are familiar with, the octets or the 4 set of octets that we know. But for the internet gateway, the associated route table IP address is always going to be this 0.0.0.0/0. Okay, essentially what this implies is everything, right? So that means when the destination says everything and it is associated to a gateway, which is nothing but a router that bridges the gap between two different networks. So what this is saying that any kind of communication from the outside world will be carried out through this gateway, whereas the VPC router, which is called the local target, right, will allow you to carry an IP address. So this is basically composed of a lot of different IP addresses, right? So in this particular example, you need to figure out two things first, whether you are using IPv4 routing or whether you are using IPv6 routing, because that kind of determines that how many IP addresses are jam-packed in this CIDR block. This is a block, right? So you have to think in terms of this entire block, and then it's not an array, okay? So please don't be. So each of these indexes will consist of an individual IP addresses up to, let's say, IPK, that you can choose individually and then assign to individual EC2 instances that are out there, right? So this essentially, that is what it is kind of implying, okay? So that is what you need to keep in mind, right? So going forward, just another note, again, as we already discussed about this, that all your public subnets have a public IP address that is associated with it, right? And that will essentially allow it to communicate with the outside world. The outside world could be any computer that does not belong within the trusted boundaries of AWS's platform, or it could be some other AWS service that is hosted outside of your VPC environment, right? So you have to keep in mind that there are certain services in addition to service like EC2 that can be associated or hosted or declared within the subnet itself, right? So for example, if you're trying to attach a storage volume, right? Like the EFS volume, not the EFS volume, the file system is different, right? Basically the block storage volume that you're trying to kind of initialize your EC2 instances is that your EC2 instances have some sort of storage associated with it that can be declared within a subnet. But if you think of other services like the S3 service, okay, or the database service, those services are not going to be present or declared within the subnets that you have created for yourself, right? Either you're using the default or you create your own VPC and you create your own subnets. It is not going to be present there. So it is basically going to be present outside this red boundary that you see, which is the trusted boundary of your VPC. So essentially that also falls into the category of having to communicate to that service back and forth in a bidirectional way using the gateway routing. Okay, so that is something that you have to do. All right. Similarly, private subnets do not have that public IP address associated with them. And as a result of that, since there is no public network IP address, private subnets cannot directly communicate with the gateway, right? They have to reroute their traffic through the public subnets, and the way the communication takes place between any instances that will be assigned to a private and a public subnet is through the use of a VPC router, right? And as we discussed, you can create multiple VPCs within a region. So that means, as we were just discussing, if I am in the Ohio region, I can create more than one VPCs just within the Ohio region, right? So they will become like a cluster of different VPCs that are running, okay? In addition to that, you can create VPCs across multiple regions. So that means I can create a VPC for Ohio. I can create, let's say, 5 VPCs in Ohio. I can create 6 VPCs in Virginia. And I can create any number of VPCs across all the different availability regions that are available, right? And you have to keep in mind that each VPC will have a different block. And this is the important highlighting or the emphasis term here, block of IP addresses. So that means when we talked about this, that is for each VPC, there will be a block or a range of IP addresses that will be available for your disposal, depending on what kind of IP protocol you're using, for you to assign them to the different EC2 instances that you're creating, okay? So let's understand this CIDR block notation, but before we go there, let's look at all of this discussion again through the console interface. So here, I'm logged in as an IAM user. So if you remember in the last class, we discussed about the IAM service, talked about creating permissions and policies, creating user groups, and then we created a user, assigned that to the admin group, and that's how we came to this position. I'm in the Ohio region. There is nothing specific about being in the Ohio region other than the fact that it is the closest to us. So that's why we are using this for our class exercises and stuff like that. So here, if you go into subnets, right, looking at the left vertical menu, so you can either choose the left vertical menu to kind of identify the individual factors, or you can go to the VPC dashboard to look at an overall, like get an overall view of all of the different things that are available. So if you look at here, you can either, browse through all of the different features that are available within the VPC through this overview dashboard, or you can choose these individual components which are there, which is nothing but another replicated way of showing all of these different features from the dashboard, right? So subnets by default is going to be 3, and the default subnets are always public in nature. So you can go into that subnet and you can check each of these different subnets and you can see the different features that is available. So here you can see that this subnet has an IPv4 IP address. Okay, so it's using the IPv4 protocol, and this is the range of IP addresses that is available. Now you may ask yourself that if we say that, oh, this is a range of IP address, then how many IP addresses? That is the question that you need to understand for those who are new to this CIDR block notation. Is that, okay, so this is my range, this is like how it is being represented, right, for the range of IP addresses that is associated to this particular subnet. Okay, so what is the individual IP address? Because remember, the individual IP address will be a set of these octets, right? This complete set of octets. So if I get something like 72.31.16.0/20, then what are the individual IP addresses? Because those are the IP addresses that if you are doing manual assignment of IP addresses that for your EC2 instances that you will create, then you need to know what is available, right? And you need to kind of discuss or have an understanding further that what will happen if you further chop it down and create subsets of your CIDR block, right? So here we don't have any IPv6 addresses, right? It tells you 4091 IPv4 addresses are available for assignment. That's a pretty big number, right? But the question you should have at this point of time is like, how does this convert to this, right? And what are these individual values, right? Where do we begin, right? So intuitively, I believe that everybody should understand the fact that the first three octets is going to remain the same, right? So it will start with 72, 31, 16, it's going to remain. But what happens afterwards, right? How do you change that? And what is the last value? What is the first value? So that is what we need to essentially understand, right? So you can also choose the option when you're creating your own VPC to not assign it to a public IPv4 address. Basically, this is what enables you to communicate with the gateway router. So you don't have to deny this, right? Because essentially there will come a point of time when you will need to communicate, if not with anything on the outer world, like a local computer, then other Amazon services, which is going to be present outside the boundaries of your VPC, right? So then you cannot just rely on the VPC router individually, right? You need to kind of have the communications go through the gateway to bridge the gap between those two networks, right? There is also a route table. So this route table is basically your VPC router. So if you go there, you can kind of select those individual route tables, and it will show you that since this is a public subnet, it has a open or like a public IP address or the destination address to the outside world, which we already discussed, that if you see something like this, that is all zeros, then that basically means everything outside, okay? And then again, we see the CIDR block that is associated with this particular subnet, okay? Which is associated to the VPC router that is present here, okay? So in this way, you can kind of analyze the different features that is associated to each subnet or the overall features if you're looking for a specific feature. So for example, if you want to look at the route table overall, that is for all of the different subnets that are present, then instead of looking at your VPC or your individual subnets and then checking it out, you can simply go to the route table and then you will find that you will have the same information there as well. So here you can see the owner ID is present. Remember that we created an alias here. So that is why we see the alias name that is being shown at the top here, rather than this 12-digit number, which typically is used. You can check out the features. And if you want to edit things like that, you can go to your internet gateway and you can check the ID of your internet gateway and stuff like that, okay? And then anything that you want to kind of do. So here you can attach a VPC to the internet gateway. You can detach the internet gateway. You can add some optional tags in order to make it easier for you to search different services and stuff like that, right? So anytime you want to do some editing with anything that is existing in terms of the resources that is being assigned to you, always pay attention to the top right corner. Once you select something, you will get that action that is available to you, right? In addition to that, yes.
Can you show this route table, what it maps to in your diagram?
Say that again. I did not fully understand your question.
This route table is a resource, right? So where it maps to in your diagram, which you shown earlier in your.
Oh, okay. I understand now. So this route table specifically is this point here. Okay. And the internet gateway is here. That's separate. So that destination which says all zeros, basically it represents this part here, whatever is outside or on this side of the internet gateway. And that CIDR block notation that we saw, which is 172 point something, that is basically associated with this particular route table, and anything that you assign will be able to communicate with each other. And if it is public, then with the internet gateway through the VPC router.
So one subnet it will be part of only one VCP router.
No, the VPC router basically connects all of these subnets together.
Yeah. So yeah, one subnet will be connected to only one VCP router.
One subnet will be connected. So there is one VPC router, regardless how many subnets that you have, they all communicate using that VPC router with each other.
Okay.
Okay, and the only exception is if it is public, then you can forward that communication to that gateway as well. If it is private, since there is no public IP addresses that is associated, you cannot essentially communicate. Okay. In addition to that, there is also security policies that you need to kind of declare for your subnets, and we will come to that. There are two types of security policies that you can create. So if you want to edit your security policies, so one of the first policies that we talked about, I just briefly mentioned over it, is network ACLs. Sometimes it is just called as NACLs. ACL stands for access control list. So basically, if you go into these access control lists, you will see all the outbound policies and the inbound policies. So here, if you want to edit any kind of existing policies, you can just, again, as we discussed earlier, you can edit this inbound rules and you can change that source and destination. So let's say, instead of saying that everything that is outside the trusted boundary of a VPC will be able to communicate with the VPC, since we're talking about an entire subnet itself, right? The public subnets that are there. Instead of doing this, if you want to say that only my local computer, which has a specific IP address, will be able to communicate with the EC2 resources that is present inside a particular public subnet of a given VPC, then you can change this source IP address. So you can go to edit inbound rules, right? Then you can change this information here and you can specify what IP address you want specifically to be able to communicate from the outside world to your EC2 instance. If you want to add new rules, you can basically add a new rule. Here, you need to provide a rule number. You can provide any number here, right? This is not specific to what, this has nothing to do with the functionality as such. So just give it some ID so that you can recognize it. And here in the type of the rule that you're trying to add, Amazon provides you with all of the different types of, port communications that can take place. So it could be a TCP communication, it could be a broadcast communication, UDP communication, if it is coming from an ICMP communication, okay? So all of these different things, if you're trying to establish an SSH, that is a port 22 communication, an SMTP communication for emails and those kind of things. If a web server is trying to communicate from the outside world to your EC2 instances, then that is going to be a DNS-based communication from port 53. Another web service that is separate, which is not using Amazon's DNS service, which will be HTTP 80 port. So you get the idea here that you have to identify what type of communication that this particular subnet is going to receive. And if you want to establish that kind of rule, that inbound outbound rule, then you can specify that here within the category of network ACLs or NACs, right? And here you can decide whether you want to allow or deny it, right? So it's not just about allowing connection as well. If you want to blacklist certain IP addresses, then you can essentially specify those IP addresses and the type of communication that will take place. And you can essentially deny them explicitly if you want to blacklist them, right? So that is how you can essentially blacklist them. So one thing to keep in mind is that when it comes to security policies, network ACLs is applied on the subnet level. So that means if we go back to our diagram here, there are two levels of protection that will be applied on top of our EC2 or on top of our VPCs, right? So here, this is a public subnet. This entire public subnet is protected by NACL. Okay, but the way it does it is a little bit different, and we will talk about it by understanding the two types of firewall. In addition to NACL, within the subnets itself, for individual EC2 instances that you're going to declare, there will be another layer of security policies that will be present. This one is known as security groups. Okay, so that is what the second category of security features that we see here is security groups. Now, security groups without the presence of any resources declared within the subnet is not going to show anything. So you're not going to see anything specific here because right now, these security group by default is present, but it is not associated to any resource because we have not created any EC2 instances. So when we go to EC2 instances and when we create those resources, then we can essentially see or we can add different rules that will protect further, in addition to the network ACLs that we can declare our EC2 instances, right? They both have the same objective, protection, right? Make sure that you allow only the things that you want to allow it to communicate with, right? But the way they do it is different, conceptually speaking. The functionality is a little bit different, right? So we will talk about them. Similarly, if you want to kind of assign an elastic IP address, which is basically a static public IP address, which is not going to be lost if you stop your EC2 instances and things like that, then you can create these elastic IP addresses here. Remember, in order to create and allocate an IP address, Amazon will not charge you. However, if you create and allocate an IP address and associate that to your subnet, but you don't use it at all, right? Then Amazon is going to charge you. Okay, so that is something that you want to keep in mind, right? So these are all of the different things. So if you have any kind of DNS firewall that you need to create, which is specific to your web server hosting, then you can kind of create your root groups here. You can create the domains that you want it to communicate with and those kind of things, which is kind of similar. Then you can create separate firewall resources, just like we are familiar with our local computers within this VPC. So all in all, essentially what this VPC enables you is to get you or give you an entire glimpse of everything that is happening within your infrastructure, your networking infrastructure. So this is like your starting point of setting up the network. Once the network infrastructure is set up, then you can kind of move forward and initialize all the different resources that will be present within this network infrastructure, right? So again, keep in mind that if you go to your VPC here, then you can create further VPCs here, okay? And any kind of additional actions that you want to do, then you can create these or you can perform these actions by using this action button here. You can also delete the default VPC if you have created your own VPC and you don't want to use the default VPC at all, right? So basically, that is kind of the overview of all of the different things that you can do with this VPC dashboard. Okay, so moving forward, let's talk about the CIDR block a little bit because that will take some time. Not time, but as long as you are kind of familiar with how network IP addresses work, it will be easier for you to understand how classless interdomain routing will work specifically, right? So as we all remember from your basic computer network classes, right? You represent your IP addresses as a set of 4 octets, okay? And these 4 octet representations can be binary, right? So there means that you have 8 bits of values that is separated by these 4 positions, right? So that means if I take an IP address like 10.1.0. let's say 23, this is the nature of a typical IP address. Okay, so you have 4 different octets. Each of these octets is a decimal representation as we see it for human interpreting purposes, right? But the implementation part of it is actually basically a binary, right? And a binary is of 8 bits. So what happens is that the values essentially can range from 0 to 0 with 8 bits here. So this is essentially a total of 8 bits, okay, to all ones, because that is how binary essentially works, right? So when you take this conversion from binary and convert it to decimal itself, then the range of values that can be present for each of these 4 fields that represents the IP address ranges from 0 to 255. Okay, so that is a total of 256 because you're thinking in terms of 2 to the power 8, right? Because this is a binary representation and you have 8 bits of field. So the total range of values that can be represented, if you transform that into decimal value, right, that is going to be 2 raised to the power of 8, which is basically equivalent to 256 different addresses, right? So remember, since it starts from 0, it will end at 255. Okay, that is composite of 256 values. All right, so that's basically computer notation. It's always the indexing is going to start from 0, right? So the two things that you need to remember or recall from here onwards is the 0 is basically always assigned to the network or the subnet. Okay, it's network or the subnetwork itself. So that is what something you have to remember. All right. And essentially, the 255, that is the last portion, is always assigned for broadcast-based address. All right. So give me 1 second. I will be back in 1 second. Just give me 1 second. Okay. So as we were discussing, the 255 is always associated to the broadcast address. That is, if you want to broadcast any kind of information from your VPC, then you basically have to use the 255 part of it. And then the 0 part is assigned to the network itself. That is, you cannot take the 0 part of the IP address. So for example, if you have something like 10.1.0.0, you cannot assign this to any specific machine, because this IP address essentially is the IP address of the network itself. And in addition to that, if you have 10.1.0.255, you cannot take this IP address either and assign it to any kind of machine, because this is basically your broadcast IP address that you have to use in the situation that you're broadcasting any kind of information. So what this information or this piece of knowledge essentially translates to is basically you can assign to the machine the IP addresses whose value ranges from 1 to 254. So basically we have to drop the 0 part and we have to drop the 255 part at the very end, right? So we are only talking about the last part or the last field of your IP address itself. So that is something that you cannot use. The other piece of information before we can start discussing specifically about CIDR blocks is that what type of IP addresses you're using. Are you following the IPv4 architecture or are you following the IPv6 architecture? Because based on, depending on what kind of architecture you're using, your translation table of converting a CIDR block to regular ranges of IP address is going to vary. So always remember is that the IPv4 IP address space is a 32-bit architecture and the IPv6 address space is basically 128-bit architecture. So now armed with this pieces of information as a little bit of background knowledge, let us look into what a CIDR notation is going to be like, right? So here, if you think of your traditional IP address, we just talked about it, is that you have 4 different subnet masks, right? So that's what we call individually to each of these fields. And we also kind of established the fact that these values can range from 0 to 255, okay? So if your subnet mask is basically on the first set or the first field, then that becomes your class A IP address. So remember, there are 5 different classes of IP addresses, right? The last one is not, you cannot use that for day-to-day use. That is kind of reserved for the engineering task force, okay? Internet engineering task force. So basically you have the class A IP addresses, mostly for businesses and large organizations and stuff like that. Then class B and class C IP addresses, they can be used by the public. Class D IP addresses are mostly kind of reserved for like multicasting, broadcasting, and those kind of purposes, specifically speaking, right? So in traditional IP address notations and stuff like that, you use these subnet masks to represent the classes of IP address. So if I do something like 255, that is the entire range of values that is present here. So I'm masking that particular field. And then the rest of them is 0. Again, 0 is something that is available, as we already discussed from our discussions on the gateway policy, the internet gateway that we were talking about, where everything was 0, that kind of represents everything, right? So that means if you mask this and the rest of the 3 fields are free, so that becomes your class A IP address. So similarly, if you think of class B IP address, you will have to mask the first 2 fields, and then the rest of the 2 fields are free. And then similarly, in the same fashion, the first 3 for C, and then you have D, and then class E is basically reserved, and you don't essentially see that publicly for your public use, right? So now, if you see a CIDR block like this, right, and this is the CIDR block that we saw here, maybe we can use the highlighter. So let's say if your CIDR block is given like this, and we saw something in terms of 172 point something, but that is fine, right? So here, this is the first thing that you're going to see. You're going to see, let's say for this example, a value of 92.168.1.0/24, right? So we already have two pieces of information that we know, right? So that two pieces of information is the fact that the 192.168.1 is the network IP address, right? And when you add a 0 to that, that is going to be the IP address for the entire subnet itself, okay? Now, you also know for a fact that whatever the last number is going to be in this particular octet, right? So that means whatever this value's last number is going to be, that is going to become the broadcast address. It is not necessarily going to be 255 itself, because 255, that discussion is based on the fact that here the values can range from 0 to 255. If the values range from 0 to 255, then the last address will be broadcast address. And essentially that is what the generic discussion is all about, is that this 255 is mostly reserved for broadcasting purposes, right? But there can be situations where your ranges of values that you can use for a particular network or subnetwork does not go up until 255, right? It goes less than that. So if you have something like, let's just take for the sake of discussion, if you have something, let's say, going from not 24, let's say 32 to kind of 128. So this will be the last value at that point of time in that available IP space, right? So this will then become the broadcast address or the broadcast value number for that particular subnet, if this is the range of values that is available for use. So you have to keep in mind that it is not universally applicable that 255 always becomes the broadcast address. So that is why here in this discussion specifically, we do say the fact that 0 is the host. Well, because it starts from, as far as this notation is concerned, it is starting from 0, right? So that is the host. But it never talks about what is the end is, right? So we will kind of discuss here in this particular instance, we will get the whole set of values. But you always have to keep in mind that whatever the range of values is, the first value is always going to be the network's IP address, and the last value is going to be the IP address space for broadcasting from your network. Everything in between is what you can assign to individual machines. So that is the piece of information, or that is how you want to kind of remember this information. Now, the only tricky part here, or only new part here, is for those who are unfamiliar, is what does this /24 refers to? And this is where the piece of information where we're talking is that we need to know whether this is an IPv4 architecture and IPv6 architecture comes into the picture. What this helps us understand is, let's say if this is an IPv4 IP address space or a CIDR block with IPv4 assigned, right? So that means IPv4, we know the fact that has 32 bits, right? What you do is you take this value here, that is 24, and then you subtract it from your architecture's total capacity. So here the architecture's total capacity is 32. The CIDR block says 24. So you do 32 minus 24, and that gives you 8, right? That is 8, right? 6 plus 2, 8. So now, since we know it is a binary representation of each octet, what you need to do is basically you need to take 8 and then raise it to the power of whatever the result of this subtraction is. So in this particular case, the result of the subtraction is 8. So that gives us 256 different values that can be used in this particular instance, right? So that means I can take, or I can go from 192.168.1.1, because remember 0 is for your network IP address, till 192.168.1.254, because the last number is going to be, this is 256 in total. So that means it can range from 0 to 255. So then 255 is the last number which need to be used for broadcasting. So that means the machine IP addresses will range till 1 to 254. Okay. Again, always remember not 0 and 255, but in a more generic way, remember the first value is your host or your network's IP address. And the very last value is always going to be your broadcast address, right? So those are the two things that you have to keep in mind, right? So let's take another example. Let's say now instead of having starting with the starting value from 0, let's say we have a starting value which is something a little bit different. Like we are talking about this fact that it might not be 0 or it might not be 255 at the end of the day. So let's say if we have a starting value that is 128, right? So, and then we have a /25. And then the question is, how do you translate this CIDR block into the regular range of IP addresses or the traditional IP addresses that uses subnet masks that we are familiar with, right? So we use the same policy. We first ask ourselves whether this CIDR block is in the IPv4 space or in the IPv6 space, because you can easily understand that if this is not IPv4, right? If this architecture is essentially using the 128-bit architecture for IPv6, then this formula and the number that can be kind of associated with it will be completely different, right? So instead of doing 32 minus 24, you basically will have to make this 32 into 128, and that is going to give you a very large value, right? Essentially, that is why the discussion is the IPv6 address space is exponentially much larger than the IPv4 address space. Not that the IPv4 address space cannot hold it, but essentially at this point of time, it's just saturating to a certain degree, okay? So coming back to our discussions here, you have 32-bit, assuming that the example, this is in the IPv4, you subtract it from 25, that gives you 7, right? So 5 and then 2, that is 7. Again, you know that is the binary representation. You take 2 raised to the power of 7, that gives you 128, okay? So that is the amount of individual IP addresses that will be available to you. So what happens here is 128 times 2 is basically the midway point of this 256, right? So essentially, your starting IP address will be the first number. So that means it is 128. So that will be the network IP address. The last IP address, so here we have 128 values that is there, right? And it is starting from 128. So if you add 128 and 128, so it goes up till 256. So that means since the notation ranges from 0 to 255, the last number is going to be 255 here. So that is going to be your broadcast IP address. So anything that is in between 128 plus 1, which is 129, to the last number minus 1, which is 254, that will be the available machine IP addresses that is available at your disposal, and that is what will be assigned to the CIDR notations, right? So now, another example that we can kind of extend this further into is like, let's say if you take an existing CIDR block and you want to chop it down further into smaller subsets of CIDR block and maybe do whatever you want with it, essentially assign that to any further subnets that you are trying to create, right? So if you want to chop off, let's say an existing CIDR block in half, so what will be the CIDR representation of that notation, right? When you chop it off. So here, what we are doing in this example is we want to take this CIDR block, okay, that is there, and we want to chop this in half, and we want to find out now, instead of finding what is the available range of IP addresses that we already know, we want to know what will be the CIDR block notation or representation when we chop this existing CIDR block into 2 child CIDR blocks, right? So we already know that this is basically 128 address spaces that is available within this parent CIDR block, right? We just computed that based on this notation, right? So if you chop 128 in half, essentially that is going to give you 264s, right? 64 plus 64, that is basically the midway point of your 128 block. So if you want to figure out that in terms of your binary representation, 2 raised to how much is 64? Because remember, previously, we had 2 raised to this value, which is available to us, and we use that to compute what is going to be the value here. But in this particular exercise, or in this example that we're talking about, we know the value here. We want to find out what is x. That is, we are just doing the opposite thing. So right now, we can say that 2 to the power x is 64, then what is the value of x? So that is kind of straightforward here, that we understand that it is going to be 6, okay? So now, if you want to now use this information and convert it into a CIDR block notation, assuming the fact that you're still within the IPv4 address space, you do 32 minus 6, which gives you 26. So now, if you chop off your parent CIDR block, so you have the first CIDR block, which starts from the original location, which basically is the starting point of the parent itself, and it goes with /26, because that is what we computed here. And then the second block is going to start after 64 values, that is 128 plus 64, which is the midway point between 128 and 256. that gives us the starting point of 192/26, right? So this is how you need to remember or translate CIDR blocks back and forth. That is, if you're given a CIDR block, how do you find out the available ranges of IP addresses, the actual IP addresses? And the opposite of it, that is, if you're given, let's say, how many total number of IP addresses are kind of jam-packed into that CIDR block, if you want to chop it off, then what will be the new translated representations of the child CIDR blocks that you're going to create from the parents, right? So I hope that clarifies your understanding of how to kind of represent or how to kind of analyze and comprehend when, if you go to any of these route tables and stuff like that, and then you see a CIDR block notation like this, and then you try to compute what you're going to do. So here, this CIDR block notation, you can try it as a self-exercise. This is, we already have discussed the fact that this is within the IPv4 architecture. So what is the available range of IP addresses that is present here? You can just follow the same thing. You can do 32 minus 16, which is going to give you what? How much is that? 32 minus 16 is? No one is present?
16.
Thank you. Right? It's just a check. Okay. So, and then what you do, you just raise it 2 to the power 16. So what is 2 to the power 16? Can somebody tell me? Quickly. What is 2 to the power 16? Anyone?
Six double 536.
Okay, so that is the available range of IP addresses. Do you think that is correct? Think about it, okay? As a self-exercise, think about this task, that how would you translate this to the actual set of IP addresses, right? So this will be an interesting exercise for you to test out your understanding about the CIDR block notation. Remember, this is not changing how you represent your IP addresses. This is just a representation which is kind of packing a lot of different ranges of IP addresses values that is available to you, right? So essentially, that is what it means. All right. So that is what you want to keep in mind. So please do try out if you're interested in kind of digging a little bit deeper into how this CIDR block is translated to actual range of machine address values. Try to do it based on the discussion that we had and try to find it out that what the values are going to be like. Okay. So we have already discussed about setting up VPCs, and we have talked about all of these different individual features. That is the internet gateway. So what we want to talk about now is specifically the implementations of the security groups and the NACLs. That is specifically what we want to do. And what is important before you proceed any further, right? And try to understand, how conceptually these two different policies work, is you have to always remember, and this is an important piece of information for those who are new to this, is that the security group is going to be applied at the EC2 instance level. So as we discussed in this diagram here, somewhere, right? So here, this boundary here is what the security group is. And the network NACLs, or the network access control list, protects your entire subnet itself, right? So this is one piece of information that you have to kind of memorize if you're new to this once, until it becomes your understanding that this is how it works. So always remember that a security group is applied to the EC2 instance level, right? So for each set of EC2s, you can group multiple EC2s that can belong to different subnet to a particular security group itself. Remember, it does not have to be kind of consolidated to a particular subnet itself. You can have EC2 instances that can belong or that can be declared across different subnets, okay, to belong to a particular security group, because security group is nothing about other than a set of permissions of what traffic you're going to allow to communicate to your EC2 instances, and what traffic will be going out of your EC2 instances, and what will it communicate with, right? So this is something that you have to remember, that again, security group, EC2 instance level, okay? And you can use any number of, or you can cluster any number of EC2 instances within a given security group, regardless whether they belong to the same subnet or not, okay? So that is what you need to remember. Whereas NACLs, or network ACLs, or network access control lists, is applied on the entire subnet itself, right? So that means each subnet can have their own independent or individual network ACL policies, or you can group all of the different subnets that you have within your VPC to be a part of a given NACL, if you are pretty confident about the fact that you have addressed all of the inbound policies that is required. Okay, so that is the two-layered security filtering that you have for the network traffic that is going to take place to and from your VPC, right? So that is what you have to remember, right? So we have already discussed this part as well. That is how you can edit, or where you can add the different inbound and outbound rules for NACLs. And also the same thing goes to security groups as well. One thing that you have to keep in mind is that when you are looking into security groups and everything that is written in red, this is something that you would want to remember, okay? That security groups by default will deny all the traffic unless you specify explicitly to allow a certain traffic into a particular EC2 instance or into a particular security group, which has a clusters of EC2 instances, right? So since we have not declared, as we already talked about this, any EC2 instances, right? Because this SG is applied to the EC2 instance level, we just see the default security group out there that we talked about here, right? So this is the only security group that is created right now. So when we create our security groups, then we are going to specify, or we have to specify explicit inbound rules, because the property of your security group is to drop or deny all traffic into the security group. Nothing can come in, right? So here, there says that there is one inbound rule and there is one outbound rule there. So what could that be, right? So if we go there, we will notice here, it's always about what is going to be the source that is going to communicate. So this is where we are in the inbound rules, right? So the source is basically, the destination is always going to be whatever component lies within the security group. The source is what is trying to communicate, right? So here you can see that the source is the security group itself. So what this is kind of indicating is that as long as any of the resources belongs to the same security group, then there will be communication between them. Again, I will repeat this information, okay, that this security default, the security group policy that is there, the security group rule that is there, it specifies itself as the source. So if you want to kind of visualize this, if you want to think about it this way, what this is saying is that if this is a security group within which you have different EC2 instances, and this EC2 instances may or may not belong to the same subnet, right? But as long as they belong to the same security group, and if there is proper routing that is established between them, then they can communicate with each other. The security group is not going to flag that. And this is coherent or in sync with this logic here that we talked about, that it will deny all traffic from outside. So that means if there is a communication, even from another EC2 instance, which may not belong to this security group, then this security group will basically drop that traffic, right? So that means when we actually go ahead and start declaring our EC2 instances, and we will have to associate security groups to it, we will have to specify the communications that we want the security groups to allow. So this is a very strong policy that is going to be applied here, okay? So that is what you have to keep in mind. So this slide is basically just the discussion that we talked about here, that the source being the security group itself, it is going to allow all communications within all the instances that belong to that same security group, or it will drop everything else. So again, just like we discussed with ACL policies, if you want to edit the inbound rules, you simply click on edit inbound rules. Then let's say if you want to add a custom TCP protocol, or let's say if you want to add a web server hosting communication. So if you select that, it is automatically going to select port number. Then you can specify the different CIDR blocks that is available to you. Okay, so you can see here the different groupings that are given to you. You can select the security groups itself, or if you want the security groups to allow communication to the public world, then you are essentially going to select everything, which is what this representation is going to give you, right? And then you can give an additional description and specify what this policy is all about. It's always helpful in a production environment to provide documentation as to what you're trying to do, right? So that is the way where you can edit this. And we will come back to this when we declare our EC2 instances, and we will add our policies and not use the default. So what is important for us to figure out conceptually is what is the difference between a security group and a network ACL. And to understand this, we have to basically know about the conceptual differences between two different types of firewalls that are out there. Okay, so the first one is known as a stateful firewall, and the second one is known as a stateless firewall, right? So you can read through this table, which kind of talks about the distinct differences between stateless and stateful firewall. But essentially, what the major difference is, to kind of boil it down to the core idea of these two different concepts, is that by default, the stateless firewall is going to drop all of the different traffics, right? Whereas if you have, a stateful firewall is going to drop all of the traffic. It's going to check both inbound and outbound. Whereas if you have a stateless firewall, if the inbound is allowed, then the outbound is also allowed, right? So that is basically the basic differences or the core functional difference between them. But if you want to look into the difference points or the differentiating points, in addition to that core idea, right? So you can look at it in terms of scalability, you can look in terms of fault tolerance, you can look in terms of the implementation complexity, and then you can look in terms of the amount of information that you have to retain in order to make the firewalls work. So basically what I kind of narrated here are the categorical aspects where these differences are, right? So this is just the discussion here, but these are the categories. So this is about scalability, fault tolerance, implementation complexity, and additional information that is required in order to implement them, right? So if you think about it, if you think about stateless firewalls, and when it says that it does not require the server to retain information about the state, so it doesn't need to know what is happening or what kind of request is coming, from whom that request is coming, what is the port number. It doesn't need to retain those information, right? So it just checks what is happening there, and it will just based on that dynamically decide whether or not it needs to allow it or it needs to drop that particular traffic, right? So if you think in terms of a typical communication that can take place between which the firewall exists, right? So take the most simplest way of communicating, right? So that is basically you have a user in the outside world, and it is trying to communicate with your web server, which let's assume that is hosted by an EC2 instance that is present within your VPC and stuff like that. So any type of communication in a web server, we all are to a certain degree familiar with the fact that it takes place with the help of a HTTP request response cycle, right? So this is how RESTful web service essentially works, right? So what will happen is that the user will make a request. So at that point of time, the user will become the source, and whatever port number the user is making the request from, that will be flagged. That will come to the firewall, and the firewall will make a check whether or not to allow that, okay? And depending on stateful or stateless, how that check takes place is going to be different, which is the core ideology. And then it is going to send it to the destination port, which is specified in the HTTP request packet, which will probably be HTTP 80 for a typical web server, right? That is the port on which the web server might be running. What will happen is then the web server will do its stuff. Then it will send the response packet back. When the response packet is sent back, then the source port becomes the web server itself, right? And then that packet arrives at the firewall and it checks the outgoing traffic. Now, whether it checks or not is where the major distinction between the functionality of stateless and stateful firewalls are. So we'll come to that, right? And then here, within the response packet, it will also specify the destination port, which is basically going to be from wherever the request packet originated from, right? So typically, during this request response cycle, what this firewall entity is going to see is the incoming traffic and the outgoing traffic. So the incoming traffic, the source is user, and the outgoing traffic, the source is the web server itself. So you always have to think in terms of the web server, because this is your resource, this is what you're trying to protect, right? So it will see the protocol, it will see the source's IP address, it will see the destination's IP address where it is requesting the response from, it will see the source port, it will see the destination port. So typically, this is the different fields that a firewall basically deals with, right? And similarly, in the outgoing traffic, it is going to see the exact opposite. So everything will be flipped, right? So that means whatever was source in the inbound traffic will become the destination in the outbound traffic, right? So what happens is that if you are dealing with a stateful firewall, okay, it is going to allow the outbound traffic if the inbound traffic is already allowed. Okay, and in stateless, it will check both the inbound and the outbound traffic. So again, I will repeat this. If you have a stateful firewall, then it will allow automatically by default the outbound traffic, okay, if the inbound traffic is allowed for that particular communication of HTTP request response cycle. Whereas if you have a stateless firewall, then it will allow the rules for both inbound and outbound traffic after checking it both times. So it doesn't matter if the inbound came, and it will allow the outbound by default. It will check both of them both times. Can somebody tell me, by looking at this particular table that you see in front of yourself, is why the stateless firewall has to check both ingress and egress, or inbound and outbound traffic, and why the stateful firewall can allow the outbound traffic by default if it has verified that the inbound traffic is allowed? Can somebody elaborate on why this is the case by looking at this table here for hints of your answer? Can somebody give it an attempt, please?
Stateful would be storing the IPs somewhere.
Right. So if you notice here, the very first row, a stateful firewall is essentially going to save the information about a session. Okay, so essentially in this kind of communication, we say that this kind of request response cycle is done with the establishment of a session. And whenever a session is established, there is a cookie that is associated with that session that stores the information of the source of the inbound traffic, which basically is the user in that particular instance. And then it knows where the request came from. So when this inbound traffic is coming to the firewall, and the firewall will save all of this information when it sees it for the first time. So if the inbound traffic is allowed, then it knows that the outbound traffic is for that same pair, that is the web server and whoever made that request, and it is going back to them. So it doesn't need to check that anymore because the information, since it is a stateful firewall, is already saved here, right? So it can default allow the outbound traffic. Whereas in stateless, since it does not save any kind of information about the session, that is where the request originated from, who it is, what port number, what protocol, all those stuff. So it checks every time whenever it receives a communication, whether that is an inbound communication or whether that is an outbound communication, right? So that is the major difference. Now, how does this tie up to security group and network ACLs? Well, security groups are stateful firewall. So that means it will allow any outbound traffic automatically if the inbound is allowed. And this is the reason why by default, okay, security groups denies all inbound traffic. Okay, a few slides ago, we just talked about the fact that by default, SGs are going to deny all inbound traffic into itself, right? So that means if you want to allow something to come into the security group, you have to explicitly specify what that is. And when you do that, it saves that information because that is what you are specifying in the rule, and it can verify that essentially, right? And as a result of that, once that rule has already been established, right, it knows what is allowed explicitly because we have to do that. That's why it allows for all outgoing traffic by default. You do not have to specify outbound rules for security groups. So security groups have no outbound rules. Okay, it only has inbound rules. And since these are stateful firewall, or it is based on the concepts of stateful firewall, then outbound traffics are by default paired up with the inbound traffic, right? And if you allow the inbound traffic, then by the property of a stateful firewall, by default, you also allow the outgoing traffic as well. Whereas network ACLs are stateless firewalls. So that means it will check both the inbound and outbound traffic. So that means now, if you go to your network ACLs, right, then you will see here that you will have your inbound and outbound rules. But then when you create your inbound and outbound rules, you get the option to kind of specify separately what your inbound rule is going to be and what your outbound rule is going to be. But however, when you're working with these security groups, all you need to do is basically take care of these inbound rules. And then by default, your outbound rules is essentially going to be inherited by those particular information as well. Okay. So that is something that you have to keep in mind, that this is how it works with respect to the properties of stateful and stateless firewall. Okay. But as a good practice of security, always make sure that even though this is going to by default allow the outbound rules, if there is ever a requirement for you to give a different behavior for the inbound outbound traffic pair for any kind of communication that is being established, then you are at a liberty, or you have the capability to change that for security groups itself. Okay, just because there is no kind of restriction that just because you specified the inbound rules, the behavior of the outbound rule is fixed because of the nature of stateful firewall. That is not true. You can still, even for stateful firewall, independently decide or set up firewall policies that is going to be different for the inbound and different for the outbound. But just keep in mind that if you do not explicitly specify anything about the outbound, and if you allow inbound traffic, then know that by default, you are also allowing the outbound traffic as well when you are dealing with security groups, which essentially is a stateful firewall. That is essentially what you have to remember. Okay. And NACL always checks inbound and outbound traffic, regardless of what it is. Okay. So please read through this particular slide. Remember this, because this is basically the takeaways of understanding how security groups work and how network ACLs work. And conceptually speaking, this is a very important distinction that you have to keep in mind and that you have to make sure that you understand. Okay. And the other thing at the very beginning that we were talking about is when we speak in terms of communicating with the outside world, right? There are services which is not just our local computers. That is not necessarily that you will try to reach out to your EC2 instances that is here, okay, only through a local computer that sits here somewhere on the public internet, right? As we were talking about it, there are other Amazon services, okay, like this object storage S3. These are some of the examples. Okay, there are DNS services for website hosting. There is CloudFront for your delivery network, the content delivery network and stuff like that, that essentially sits outside the trusted boundary of a VPC. So that means it has to deal with the network ACL layer here, and it has to deal with the security group layers here. Okay, and remember, you can put security groups and wrap other services, which is not an EC2 instance, around as well, right? You do have the capability to do that. So this is one instantiation, which basically shows that there are certain services on AWS cloud platform, which are publicly available to everybody, right? So what that means is that if you remember, we talked about the fact of a hybrid cloud architecture, right? So that means I create part of my cloud architecture by myself. Let's say all of these EC2 and these databases, if I do not want to ship my data or stuff like that. But let's say if I want to still take advantage of the website hosting, such as a DNS service, or I want to distribute my images and videos, let's say, if I'm a content distributor and stuff like that, I don't want to store it, or I don't want to kind of facilitate the distribution of that from my organization, right? Or wherever I'm hosting this private cloud, then I need to basically connect this private cloud to these public services that is availed or provided as a service by Amazon, right? So when I connect them, basically I need the capability of these services to be visible on the internet so that I can build that hybrid architecture. So essentially, that also applies to any kind of infrastructure as a service hosting that you do on AWS as well. In that situation as well, you have to communicate through your internet gateway of your VPC to the public services that it can be accessed over the internet for Amazon itself, right? So these are also some of the situations when you need to communicate, even if you're doing a complete public hosting of your organization's cloud infrastructure, you still will need to communicate with services that are available on the internet, the public internet, and it's not going to be present within the VPC boundaries of your organization's architecture. Okay, so that is the last piece of information with respect to VPC that you have to keep in mind. Now here, I talked about this AWS client, the CLI. So please install this. I already asked you in the last class, but if you haven't done it in this class, please install it. And also for those who are working with the Windows operating system, you don't have the functionality of SSH. Actually, now you have it in the command prompt. But if anybody is working with an older version of a Windows operating system, okay, and their command prompt does not support SSH, then the alternative to that is to basically just download this software called PuTTY, okay, that allows you to establish SSH connections to your EC2 instance. So again, first check through SSH using your default CMD, okay, your command prompt for your Windows system. But if that does not work, please make sure that you download PuTTY and you use it. For those who are working with Linux distributions, or you're working with Mac OS, you can just use the regular terminal in order to kind of SSH into the EC2 instances that we will eventually be creating. Okay, so that kind of wraps up the discussion about VPC. The next thing that we can move on to is basically the EC2 service itself. So we're not going to deep dive into it, but I just want to give you just a glimpse of what it is going to entail. And then in the next class, of course, we will discuss about the the integrate details of the different features or categories of EC2 instances that you can work with, right? So just like any of these services that you work with, first and foremost, as a good practice, just make sure that you're in the region that you're working with and you are in the current account that you're working with, because accounts, is in terms of the permissions, kind of is associated with the permissions. You want to make sure that you are in the right account as well. So for EC2, you essentially just have to go to EC2 service itself. So you can see here from the VPC dashboard, you also have an EC2 global view, right? So that will take you to the EC2 service itself, because VPC is basically the network infrastructure. It's basically the skeleton, and the actual matter that is there, the organs, is going to be the EC2 service, which is the major infrastructure. And in addition to that, if you want to give database service, if you want to give file storage service and all those things, that also is present within the skeletal structure as well. Some of the other services are basically in the outside world. So you go to the EC2. If you want to create your own image, you're going to go to the service of EC2 image builder, but we are not going to be creating our own image at this point of time. We are just going to work with the templates that are there, right? So go to that service, and then this takes you to the same place where you could have gone from the EC2 dashboard. This is a global view of it. And this will give you, again, just as we saw from the VPC dashboard, the EC2 dashboard is going to tell you for a particular region of all of the different instances that you're running. If you have deployed any kind of load balancer, we will talk about load balancer when we talk about auto scaling groups, or it is better known as ASGs. If you have created any snapshots of the data for your EC2 instances that you're saving. So these snapshots are generally saved in S3 buckets in order to improve them. Auto scaling group, remember we talked about a lot about when we were discussing the conceptual aspects. We discussed about elasticity. We talked about the fact that the cloud should be able to automatically manage whether there is a need for extra instances, or whether the extra instances should be shut down depending on the usage load and stuff like that. So the way you can do it is basically through this service of auto scaling groups, right? If you want to create dedicated hosts, you want to have these, then it will show you here that if you do not have multi-tenancy and if your EC2 instances are essentially running without multi-tenancy, then it will show up here for dedicated hosts. Key pair is what you will use for authentication purposes when you're trying to SSH into your EC2 instances, or you're using PuTTY, or you're using remote desktop connection if you are specifically on Windows. That I think Mac has its own version, and Linux is a little bit tricky when it comes to RDP. But Windows is pretty straightforward. That if you create an EC2 instance with a Windows distribution and you're trying to connect to it using a Windows machine itself, then RDP is one of the sweetest way you can get a user interface itself, and you can do a remote login as you're familiar with, right? So in doing all of those things, you need an authentication secret key, right? So you basically have a key pair that you generate, and you use that key pair in order to kind of authenticate yourself when you're trying to SSH or RDP into your EC2 instances, right? So this is what that key pair is all about. You need to have your security groups, because remember, as we just discussed, that security groups are applied on the instance level. So that is why you see a security group here, but you do not see, note here, that you do not see any kind of network ACLs, because network ACLs are essentially on the subnet level, one level above that. So in addition to that, it will give you all of these different quick access buttons here. It will show you your service health. If you're running anything here, it will show it to you from these kind of instances. If you are running a server somewhere else in some other availability region, and if you want to kind of migrate it here, or if you're running it on your local instances, if you want to migrate it here, then essentially you will use this particular services. The other important thing is this left vertical menu. These things looks all flashy and nice, and it's easy to follow. Yes, that is good. But if you want to have a detailed view of all of the different options that you have for a given service, pay attention always to this left vertical menu. This is where you will get all of the major stuff. So here, if I kind of, minimize all of the different options when it comes to an EC2 instance, notice that there are only 6 different services or sub-services that is associated to your EC2 experience. All right. So, whoops. So the first one is basically everything about creating the instances. Now, remember, when you want to create the instances, we talked about the fact that we don't want to dynamically, when a user requests for a virtual machine, create an image and boot it, right? We want to keep it ready somewhere. So basically that is the image. So if you go to the images, so let's look at the instances. So here you can do the instances. You can do all the different types of instances. We will talk about it. There are memory optimized, there are GPU optimized, there are regular instances, the basic ones. Unfortunately, on the free tier, we cannot use all of them. We are restricted to only T2 micro and T3 micro. So we will be sticking to that, but we will talk about what is there, right? So we can create reserve instances, we can create dedicated hosts and those kind of stuff. So everything that is related to kind of infrastructure as a service, right? But then you also need your images, okay? So here, AMI stands for Amazon Machine Image, right? And this is basically your catalog, or in short, this is a marketplace. So that means that if you do not want to use the bare bone AMI image that AWS will provide you, so that means, let's say if you want to go with the Linux distribution, or you want to go with the Windows distribution, if you use the regular AMIs, okay, Amazon has its own version of Linux, okay, so it will install, or when your EC2 is being booted, it will give you the basic software stack that is there. But if you need any kind of specialized software stack, okay, then basically you can go to the catalog here, okay, you can create your own images for your own organization, okay. The quick start AMIs is basically the popular AMIs that people mostly use. So here you can see that we have an Amazon Linux 2 AMI, okay. So you can select x86 or ARM depending on your architecture style that you're doing. And you can see here which ones are free tier eligibles and which one needs to be paid for. So if you're going for Mac OS, for example, you cannot use that or test it out on your free tier account. You can only use the Amazon versions. You can use the Red Hat distributions. Anything that is Mac, well, you have to pay. You can use SUSE Linux and stuff like that. There is also Microsoft servers that is available. These are all free tier eligible, so you can try it out. You have the basic Microsoft Windows version as well. You can install it. If you want to install it with, let's say, a Microsoft Server SQL Server stack, then you can select that image instead of having to individually install it, right? But if you do not want to use any of Amazon stuff, you can create your own AMIs. It will go through a check, by the way, keep that in mind. You will not see it being submitted to the marketplace unless it goes through the security check of what you have done with your image builder for obvious reasons, right? And then if you want to take up or look into trusted third-party AMIs, then you can go to the marketplace. Or if you want to use to AMI, like people like us can create and submit. It's not, trusted third party as such, but there is some verification that is going on. Then you can go to those different AMIs and you can try it out and see like what they have done here, right? And this kind of gives you the option to see that if some of the users have created something which is what you need, right, in terms of software stack. So the images all goes back to the software stack, right? Because the basic distribution is always going to be there. The skeleton distribution of a guest operating system that on top of which will run your virtual machine is always going to be there, right? But what is important is to basically kind of find out is the additional software stack that you need in the image, right? So if you need, let's say here, you have the WordPress certified and it is coming from Bitnami, right, which is a part of VMware. So you can use that image and it will come with WordPress and stuff like that. So there is a lot of options that is available for you to use. Some which is coming from, so you can see here that there is 7,000 images that are available. So you can always check that out and you can choose from this option when you're creating your EC2 instances as well, right? So once the operating system is done, what comes after that is basically the storage. So in storage, basically, you can go to the volumes, you can create individual volumes, irrespective or mutually exclusive of the creation of your EC2 instance. And when you're creating the EC2 instance, you can basically connect those volumes that you have already created to the EC2 instance. So you can either do the process of creating a storage volume when you are initializing your EC2 instance, so you specify all of them step by step, or you can do it separately as well. That is, you create a volume, keep it separate. When you create an EC2 instance, you just connect that volume that is already created, right? If you are stopping your EC2 instance and you want to kind of save the current state of your storage volume, then you create a snapshot. This snapshot allows you to kind of migrate your block storage EBS or EFS to another region, kind of bring it down to your local storage or whatever you want to do, right? If you want to do it as a failover policies, you can do that, right? Network security, basically you can create security groups. You have to create a key value pair. So in the next class, when we work on this, we will see that this is the first step that we need to do, or one of the steps. I don't remember exactly if this was the very first step or not, but we will figure that out. So essentially, we need this to make sure that we can, log SSH into our EC2 instances from a different computer and then work on them, right? Of course, there's options of interfaces here, but you always need to know how to connect to it, right? You also, the important thing here is to make sure that you can edit and create your own VPC groups. So one of the exercises that we will do for our EC2 application is to create a web server, host a web server on EC2. So then we have to create a new security inbound groups because we have to access that particular EC2 instance from the outside world so that it can access that web server essentially. So the two important things here is basically key pairs and security groups, at least for the fundamental understanding. We're not going to go for an elastic IP. We don't need that. But again, remember, elastic IP is basically a static public IP address, which is not going to change even if you shut down your EC2 instance. It's always going to be there. So it is not associated to an EC2 instance, but you can link it to a given EC2 instance if that instance is hosting a particular server. Load balancing, again, we talked about this. Load balancer is the software. Target groups is basically what it is monitoring. So if you have, let's say, 4 or 5 different EC2 instances, which are all hosting a replica of your web server, then you will have a load balancer, which will monitor the target groups, which will consist of your EC2 instances. And then it will kind of make sure that all of the different traffic is not overloading any particular web server that is present there, right? And auto scaling is for elasticity. And we talked about it, is that we create a template within the auto scaling groups. And we use a different service, which is CloudWatch. We have already seen that in action when we were trying to monitor the usage pattern and figure out the cost of those things, right? But we will monitor CPU cycles here in this particular cases by installing this demo daemon shell that is going to put some stress on the CPU in order to kind of trigger the auto scaling groups to give us an understanding of how it works, right, in real time to see that it actually does, right? So that will be pretty interesting for those who are coming in the first time. So all of this, again, in the next episode of Dragon Ball Z, wrong class, okay? In the next episode of Cloud Computing at OU, we will talk about it, okay? So we'll start discussing that and we will take a deep dive into understanding the different types of EC2 instances, what are the different types of memory, what is memory optimized EC2 instance, what is GPU optimized, and all of those stuff, right? So I will wrap up here. And if you have any questions, I will take them at this point of time. And if not, we are done for today, and I will see you all next Monday in person. Thank you.